Okay, so we're going to look at quadratic inequalities today. That's the next skill in your course, and essentially what you saw at National 5 was linear inequalities, and a linear function is essentially a function where the power of x is 1. And when you were to draw this line, you would get a line that looks like that, and it would go through -3, okay, and you would then look to solve that before. So you would solve it by taking 3 over and then divide by 2. So you get 3 over 2. And that point there would be 3 over 2. Okay? And essentially, this line is bigger than or equal to 0 when x is bigger than or equal to 3 over 2. In other words, from this point here, the line goes above the axis, so it's greater than 0 at that point. Great, we did that at National 5. Now, for quadratic inequalities, the difference with a quadratic function is it isn't a straight line. A quadratic function comes down and looks like this. And if I said, if this function was x squared plus 6x plus 8, when is that bigger than 0? I would have 2 points where this line is bigger than 0. It's bigger than 0 after this root here, and that would be at -2. That one would be at -4. So I'd have 2 points where the curve goes bigger than 0 when x is bigger than -2, and it's also bigger than 0 before we get to -4. So the way we're going to solve these quadratic inequalities is using the following method, and I'd really like you to stick to this method, please. It's all about the structure. If you get the structure right of your answer, it's actually pretty easy. So what we're going to do is we're going to use the sketch to solve it, and to do the sketch of a quadratic, we're going to find the roots first. So that's my first step. So what I'm going to do is I'm going to put a little subtitle. I'm going to call it roots, and then I'm going to get the roots when x squared plus -6x is equal to 0. Okay, so factorising this, now this obviously isn't a trinomial, it's just a common factor factorising, and the common factor is x. So take a common factor out, you get x minus 6 equals 0. Then every x is made to equal 0. So x equals 0, and then x minus 6 equals 0. So x equals 6. I'm not going to be doing that bit all the time. I'm sure you can pick up on it. Now what we're going to do is we're going to sketch this to see what it looks like and then consider the inequality. So my next part of my solution, I'm going to do a sketch. I'm going to use a ruler because that's just, you know, how I roll. And I'm going to plot my roots. I'm not looking for a great deal more accuracy than this because it is a sketch. So I've got a root when x equals 0, and I've got a root when x equals 6. And I'm going to plot the quadratic. Now, you can tell whether it's a U shape or an N shape based on simply by looking at the x squared. The x squared is positive. So if it's a positive x squared, the curve is a U-shaped curve. So it looks like that. Now, I don't need any more detail in my sketch than that. That's absolutely fine. Now, what I'm going to do now is I'm going to go back and consider the inequality. I want to know, when is this curve less than 0? It is less than 0 when it goes below the axis. So it's less than 0 here, in that little section there. And if this is the x-axis, the curve goes below 0 when x is between 0 and 6. And we write that as x is between 0 and 6, but x is bigger than 0, but less than 6. And that is your final answer. Okay? Right, we'll have a look at example number 2, or the next example. Right, so same method, you're going to find the roots first. So step number 1, find the roots, and therefore I'm going to factorise it, and I get the roots when this equals 0, okay? So factorising that gets you x minus 2 x minus 4, and therefore coming down x equals 2, x equals 4. Alright, so I've got my roots, I'm going to sketch it. So I know where my roots are going to be, so drawing the axis is pretty straightforward. So I've got roots at 2 and 4. I'm not looking for a great deal more than the 2 and the 4. I know it's a positive quadratic because the x squared is positive, and therefore I want to know when is this curve bigger than 0. It's bigger than 0 here and here. Alright, so for this section, x is going to be smaller than 2, so therefore we write that as x is less than 2. And for this section here, x is going to be bigger than 4, and we just write that as x is bigger than 4. And that is it. Okay? Right. Next example, we'll go with this one. It's the same method, everything's the same. The only part that's tricky with this is being able to factorize. Okay, so I'm going to find my roots. I've got 2x squared minus x minus 3 equals 0. Factorizing that, you get 2x and x for the 2x squared. And then to get 3 with minus 1 in my center, I don't want to times the 2 by the 3, so I'm going to get 3 and 1. And therefore I want to get minus 1, so I want to have 2 take away 3. So I've got that as my solution. Now if you need to do your little table where you do your 2x and x, 1 and 3, 3 and 1, go for it. As long as you get the right solution, as long as you're able to do it. Right, so therefore this bracket equals 0, so I get 2x minus 3 equals 0. So x equals 3 over 2. And for this bracket, x equals minus 1. If we skip to the end, we're going to do a sketch. And doing the sketch, I've got minus 1 as one solution, minus 3 over, positive 3 over 2. It's a positive x squared, so it's a happy one again. So it's coming down and it's looking like this. Now, this time I want to know when is a curve less than or equal to 0. In other words, when is it below? So it goes below here and there. So therefore x is between these two values. Okay, so I've got minus 1, x, 3 over 2. So when I've only got one statement to write, I just need to make sure I get these right. Now, it's less than or equal to. So just check that, make sure that matches up with that. And that is your final solution for that one. Okay? Right, 2 more examples, and that's us. So next example, we've got this one. So difference obviously with this one is it's a negative x squared. Now we're going to do the same process. You find your roots. So I'm going to do 10 plus 3x minus x squared equals 0. Now how you choose to go and solve this is entirely up to you. And how you choose to go and factorize it. I personally would factorize it by taking a common factor of minus 1 from everything to start us off, because then the x squared is easier to factorize. So I take a common factor of minus 1, I get minus, then I get x squared, and take a common factor of minus 1 just changes the signs in front of the other terms. So minus 3x minus 10 equals 0, and then I can go on and factorize that, ignoring the fact there's a minus in there. So I've got x minus 3x, x squared minus 3x minus 10 becomes x minus 5 plus 2. Get your roots coming down, so x equals 5, x equals minus 2. The minus at the front doesn't affect the roots at all. So we're going to do our sketch, taking care this time because it's a negative x squared at the start. So I've got my sketch going on. -2 would be about there, 5 would be about there, and then go back to the original. It's a negative x squared, so therefore it's upside down. So it looks like that. Then consult the inequality. I'm looking for when is this curve less than 0. In other words, when is it below the axis? It's below the axis here and here. So I've got 2 parts, so I need 2 statements. So for this section here, x is less than -2. For this section here, x is going to be bigger than 5. And so that's your solution. Okay. Last example. Right. Just like a quadratic equation, you need to make sure you solve it when it is equal to 0. So I don't want to be saying that. So I'm going to make it equal 0. So I'm going to do my roots first. Same process. I've got -1 equals 6x squared plus 5x. And then I'm going to take the -1 over to join it. So then that becomes 6x squared plus 5x plus 1. I'm going to do my factorising. So you could do 6x and x, 1 and 1. You're going to add to get 5. 6 times 1, add 1 is 7, so that's not going to work. So let's try 3 and 2 to make the 6. 3 add 2 gives you 5. That's the combination you want. So if we got 0, and that's 3x plus 1, 2x plus 1. So therefore this bracket equals x equals -1/3. This bracket is x equals -1/2. Okay. I'm going to do my sketch. And in the sketch, I've got both negative roots. So I'm going to put the axis over to this side. I've got -1/3, which is obviously, or I hope it's obvious, is smaller than -1/2, so that comes first. So I've got -1/3. Further along, I've got -1/2. Alright, now, looking up here, because I want to see whether it's upside down or not upside down, I could take it that way, but actually what I did here was I took the 1 to this side. So I'm going to do that up here. I'm going to go back up to the top. I'm going to take the 1 to this side. So then I have 6x squared plus 5x plus 1, and that leaves me with nothing over here. So now I can look at this and say, well, 6x squared plus 5x plus 1 is less than 0, but that's positive, so it's again a happy curve. Looks like that. And I want to know when is this less than 0. So that line there actually is critical that you shift it. Not just doing it here, but shifting it there. So you know which section you're looking to highlight. So I'm going to look for the section here where this is less than 0. So it's less than 0, it's below the axis. So it's that one. So therefore x is between -1/2 and -1/3. And again, this is a critical part of making sure you know that 1/2 is -1/2 is smaller than -1/3. And making sure you get these in the right order. If you get these in the wrong order, or these are pointing in the wrong direction, you'll lose your marks, I'm afraid. Okay, well, I hope that helps.